Hi, this is Jack from Maths Forge, and in today's lesson we're going to be doing sectors and arcs. So let's take a look at our first example. Here they're asking us to find the arc length to one decimal place. The arc length is the curved length of this circle on the outside here. It's essentially a portion of the circumference of a circle. So this isn't a full circle, this is a sector. A sector is just part of a circle. So in order to find the arc length, we've got this formula here on the right. Arc length is equal to pi times the diameter times by theta, which is the angle here, over 360 degrees. So let's actually talk about what's happening in this formula. We know that this part of the formula here is the circumference of a circle. It is the outer distance of a circle. And then we're multiplying the circumference of a circle by theta over 360 degrees. So what is this part of the formula doing? Well, if you think about it, 360 is the total angle around the point, and theta is the angle that's actually being made by the sector. So if you take the angle that's being made by the sector, which is 281 in this case, and divide it by 360, this gets you a percentage in decimal form that this angle here makes out of a full circle. So let's do this one for example. Let's take theta, which is 281, and divide it by 360. This gives us 0.78. So what we're dealing with here is a sector that is 78% of a full circle. And so if the sector is 78% of a full circle, then the arc length is just going to be 78% of a circumference of a circle. So let's see what this looks like. So I'm going to take my arc length formula and I'm going to do pi times d. So pi times the diameter. In this case, they haven't given us the diameter. They've just given us the radius. The radius is the length from the center of the circle to the circumference. And the diameter is just double this. So to get the diameter, I'm just going to take 107 and multiply it by 2. This gives us 214. And so now we have the formula for the arc length, which is pi times d, so pi times 214, times by that angle at the center of the arc over 360. So putting this into our calculators, we end up with the following, 524.8. And since we're calculating a length, it's going to have units of centimeters because the radius has units of centimeters too. And if we check our answer, there it is. We'll do another one-star example. We're being asked to find the arc length to one decimal place, so it's this length here. Okay, so we'll get the formula. It's going to be pi times the diameter, and I believe that this here is the radius. If it was the diameter, the length would have been in the middle. So we're going to double this radius to get the diameter, so that's going to be 214. And we're going to multiply this by the angle made by the arc, which is 180 degrees, divided by 360. And actually, 180 divided by 360 gives you 0.5. It gives you a half, which means we are dealing with a semicircle, half of a circle. So putting this into our calculators, we get the following, 336.2 centimeters. And if we check our answer, there it is. Now let's do a two-star example. Here we're being asked to find the sector area to one decimal place. So we have the sector here with an angle of 94 degrees and a radius of 83 centimeters. So I'll just label this very quickly. This is going to be r and this is going to be theta. And so to find this area, we're going to use this formula here. Now, if you take a look at this formula, the first part of this formula is pi r squared, which is just the area of a circle. And of course, the next part of this formula is the proportion that this sector makes of a full circle. So substituting the values we have in front of us into the formula, we end up with the following, pi times r squared times by theta over 360, and theta is 94 in this case, divided by 360. Putting this into our calculators, we get the following, 5,651.1 centimeters squared. Don't forget we're finding an area, so the units are going to be in centimeters squared. And if we check our answer, there it is. Now let's do a three-star example. Here, they're giving us a sector and they're asking us to find the angle to one decimal place. What are they giving us? They're giving us the radius, so this is r, and they're actually giving us the arc length. So they're giving us the answer. This is working with the formulas in reverse. So since they're giving us the arc length, I'm going to use the formula for the arc length. And we can see here that arc length on the left-hand side, I'm going to replace it with the value that they've given us, so 387.4. And this is equal to pi times the diameter. So it's going to equal to pi times the diameter, but we don't have the diameter, we have the radius. To get the diameter from the radius, we just double the radius. So 124 times 2 is going to be 248. And now this is then being multiplied by the angle over 360 degrees. And this is what we're looking for. We're looking for this theta here, this angle. And so how we can go about doing this is quite simply just to rearrange for theta. So the first thing I'm going to do is just begin cancelling out terms on the right-hand side of this equation until we finally isolate the theta by itself. So the first step I'm going to take is I'm going to divide both sides by pi. This now leaves us with 387.4 over pi, which is equal to 248 multiplied by theta over 360. The next step is to divide by 248 to cancel out this 248 here. This is now going to leave us with 387.4 over pi divided by 248. And if you can see what I'm doing right now, I'm not actually simplifying anything. I'm just getting everything ready so I can input it into my calculator in one go. And this isn't the only way to do it, but it's the way I prefer to do it. And now on the right-hand side, we're left with theta over 360. So we're really close to isolating the theta and finding out what it's equal to. The only thing left attached to it is this 360, and it's attached via division. So I'm going to detach it via multiplication. So I'm going to times 360 to both sides. This now leaves us with 387.4 over pi divided by 248 multiplied by 360, and this gives us theta. And if we input this left-hand side into our calculator, as it looks, we end up with theta is equal to 179.0 degrees. Don't forget, we're looking for the angle, and the angle units is given in degrees. And if we check our answer, there it is. And that's it for the lesson on sectors and arcs. Commit to memorizing the formulas, and then practice them as much as possible. Practice them on finding the arc length, the sector area, and finally on reverse problems where you have to find the angle.